In this lesson, we'll be introducing vectors in 3 dimensions. Essentially, what we're looking at is now vectors with 3 dimensions, and that is that they exist in the x, y, and z axis, and that means that there are now vector components I, j, and k, respectively. So we're used to 2 dimensions, and we've played around a fair bit in 2 dimensions with vectors. And usually we're talking about the x and y axis, or the I and j vector components. Now when we turn that into 3D, we adjust those directions on the diagonal. So now I and j look like that. Now the reason we do that is so we can add the 3rd dimension, which is our k direction vector or vector component. Now that can go up and down as well. Central point here, 0, 0 is our origin. Okay, so vectors existing in 3 dimensions will have or can have components in the I, j, and k direction. Okay, so a component vector in 3 dimensions can have a dimension in the x direction, the y direction, and together they form the base of the vector. Now, the base of that vector from that x-axis creates the azimuth. So it creates an angle. That creates an angle on the base. In the 3rd dimension, that k dimension, we have a distance z, and so that is projected up from that base. So this distance z up from there. The angle that distance forms with the base is called the altitude. So depending whether we're looking at we're looking at the vector in component or polar form. In component form, vector will have a component in the I direction, the j direction, and the k direction, whereas in polar form, it will have its magnitude, which is still the length of that 3-dimensional vector from the origin to its endpoint, but it will also have an azimuth, that's the angle along the ground, and an altitude, which is the angle from that base up. Okay, so essentially that's our introduction to 3-dimensional vectors. In component form and polar form, you've got those forms there. Next, we'll start looking at how we convert from component to polar and then polar back to component.